Hello, this is Dan Alford. Welcome to the Arc Specialties Weld of the Week. This week we're talking about gas metal arc welding, which is also called MIG for metal inert gas, and it's also called short arc. But that's not entirely true because short arc is really only one of three transfer modes used in gas metal arc welding. In short-circuiting transfer or short arc, the wire comes down, shorts out on the workpiece, and then there's a small explosion leaving a droplet of metal. This happens 100 times a second or more. It's a great process for thin materials and root welds on pipe. However, it's one of the very few welding processes which are not pre-qualified by the American Welding Society for structural welds. The reason for that is it's a very low penetration process, which makes it prone to lack of fusion defects. But short-circuiting transfer is still one of the most common ways people use gas metal arc welding and has many applications in the world. The second mode of transfer is called globular. It's easily identified by large particles transferred across the arc. Each particle is actually larger than the wire itself. This only occurs at high current levels with high CO2 contents in the shielding gas. In my opinion, there are very few applications for globular transfer, but I see it being used in many factories around the world. Instead, I recommend that people go to spray transfer. Spray transfer is a bit different than globular. Spray transfer only occurs at high current levels and with argon CO2 shielding gas blends with 15 or less percent CO2, or with argon oxygen blends with 5% or less oxygen. Spray transfer is a great welding process. Very high deposition rates, which means high pounds per hour, and extremely low defect welds because we have high penetration into the base material. And yet I estimate that less than 10% of all gas metal arc welds are made with spray transfer. And the reason for this is twofold. There's two problems. The first is arc light. When you're running the high voltages that we use for spray transfer, you put off a lot of ultraviolet light, which is detrimental to the welding operators and requires special protective clothing. The second problem is spray transfer has a high fluidity puddle, which means it's very difficult to weld anything other than the flat position. So when you're trying to weld vertical or overhead, you're limited with spray transfer. The solution to the arc light problem is to let the robot do the welding. The solution to the fluidity issue is to use pulse current and reduce your overall heat input. With pulsed welding, you actually only transfer a droplet of metal across the arc with each pulse. This allows you to weld vertical, overhead, and in any position you'd like. So what you're seeing is a mobile robot, which is welding high-strength, low-alloy, 100 KSI tensile material in the field with a solid wire using spray transfer with pulse. With pulse transfer, we're able to hold a total heat input to less than 70 kilojoules per inch and make welds in all positions. So next time you're picking a welding process for one of your applications, I encourage you to consider pulsed spray welding. The filler material cost is low. There is no slag, which is particularly beneficial if you're doing multi-pass welds. There's very low smoke, and the defect rate is extremely low. We look forward to posting new episodes of the Arc Specialties Weld of the Week. If you're one of the thousands of operators of Arc Specialties equipment around the world, and you have a weld that you would like to showcase, please contact us. At Arc Specialties, we thrive on problems. Send us yours.